Hey guys, Mrs. Sands here. So we're on lesson 3. Really today is just more practice with the recursion formula. So if we were in school, I would just have you working with your partner and I'd walk around and answer questions. So since I can't walk around and answer your questions, I'm just going to pick a few of the problems from this lesson and do them in a video. And then of course I'll provide you with the answers so that you can check your work once you're done. So I have circled some problems that I want to do. First, copy down this objective that it's more practice, and we're going to be able to do really both lesson 1 and 2. If we're given a sequence, we can write the recursion formula. If we're given a formula, we can write the sequence. So if you remember the definition of an arithmetic sequence, it means that you continuously add the same number. So I'll write that it's a sequence that shows continuous addition of the same number. We like to say that arithmetic sequences look like linear functions. And then a geometric sequence is a sequence that shows continuous multiplication of the same number, and it represents an exponential function. So when we say that an arithmetic sequence represents a linear function, that's if we were to write the explicit formula. We're really still dealing with recursive formulas. We've done explicit formulas in the past, though, so I'm just reminding you that the explicit formula for an arithmetic sequence looks linear, while the explicit formula for a geometric sequence looks exponential. Another reminder is that that number that you add on multiple times in an arithmetic sequence is called the common difference. And that number that you multiply by in a geometric sequence is called the common ratio. So I've circled some problems that I'm going to do, and then you'll be on your own for the others. But if we take a look at A and try and see what kind of pattern is happening, I hope you're noticing what I'm noticing, that it looks like you can multiply by 4. So what we should say is that this is geometric. I'm going to abbreviate. We can say that the common ratio is 4. And if we were to write it as a recursive formula, I'm jumping ahead. I know what's to come. Over here on this number 1, it says go back to the do now and write a recursive formula for each sequence. So while I'm here, I'm going to write this recursive formula. So a recursive formula has 2 parts. The first part, you have to write down what the first term in the sequence is. And the second part tells you how to find the next term. So a sub n stands for the next term. I use the term prior to that, which would be an a sub n minus 1. And what do I do to it each time? In this case, I'm multiplying this by 4. If I did part B, are you noticing the pattern? We are adding on 20, which makes this an arithmetic sequence, which means that the common difference is 20. And if I were to write a recursive formula for it, the 2 parts, first part, state what the first term is. Second part, say you want to find the next term by using the previous term, and to that previous term I want to add on 20. You really don't have to put that in parentheses. You could leave it not in parentheses, and it's just as acceptable. I'm going to skip now down to K. So the direction said to state whether it's arithmetic, geometric, or neither. So if I take a look at this, it's a neither. I'm not adding on the same number each time, and I'm not multiplying by the same number each time. So this is neither arithmetic nor geometric, but I can write a recursive formula for it because there is a pattern that I'm noticing. First of all, the first term is always the easiest thing to write down, and then I can start off by saying I want to find the next term by using the term that I know. Now I left the blank here on purpose because I noticed some kind of pattern. You think about it for a second, hit pause if you need to. I noticed that if I multiply this 5 by 2 and then add on 1, I can get to an 11. If I multiply 11 by 2 and add on 1, I get 23. So if I multiply what I know by 2 and then add on 1, I get the next term. So when it's a neither, it just comes down to being, I guess, observant and using some problem-solving skills to try and figure out what is that recursive formula. Most likely on like a Regents exam, they wouldn't ask you to write a recursive formula for a sequence that's neither arithmetic nor geometric. I guess you never know though. At this point, if you know how to write the recursive formula for arithmetic and geometric, you're in really good shape. And then the neither ones, I wouldn't panic too much about. Will there be a question or two about a neither? There will be on the test that I'm going to give you at the end of this unit. But honestly, nothing too much to panic about. So let's do this next one because this is also a neither. Looks like I'm adding on 2, and then 3, and then 4, and then 5. This is one where I'm adding on like the next higher number. I'm not adding on the same number, I'm adding on like the next integer that comes in line. So the first term is 7. To find my next term, what I want to do is use the term that I know, and onto that add on, what are we adding on? If this is when n is 1, and this next one is when n is 2, to here I added on the 2. I added on the one that came after. So I'm adding on the n, not the n minus 1, not the one that I know. I'm adding on the next n. So that's why it's a plus n. And don't panic, like I said. Those are the hardest ones. And on your own, you're going to go back to the do now. You're going to tell me whether it's arithmetic or geometric, and then you're going to write the recursive formula for each one. Remember, recursive formula has 2 parts. So now let's do this next thing, the ones that I've circled. I'm given a recursive formula. This is like the next term. This is the term I know. And this tells me what to do to it. I want to add on 10 to the term I know. So I know a 29. If I add on 10, I get a 39. If I add on 10, 49. If I add on 10, 59. How many do we need? First 4. Done. So just remember that the only strange thing about this is the notation. You know how to do this. You did it when you were younger. You just keep on adding on the same number. Not a big deal. So on B, oh no, I don't want to do B, sorry. On C, this is the next term. And this tells me how to find it. This is the term I know. And this is what I do to it. I'm adding on what comes after the term I know. I'm adding on the n that comes after the term I know. So I know -4. I know that this is when n is 1. The next one will be when n is 2. The next one when n is 3. And the next one is when n is 4. The term I know, I'm adding on the next n. The term I know is a -4. I'm adding on the next n, which is a 2. Now I know a -2. I'm adding on the next n. Now I know a 1, and I'm adding on the next n. So there's my sequence. -4, -2, 1, 5, and so on. And I only wanted to do D, not because it's hard. I think you could probably do this without me, just because I guess the way it's written, I don't want you to get confused. So this is the next term. This right here is what I know. And what I know, I'm going to, I can't see that sign there, I'm going to add on 2 to it, and then divide it by 2. So you have to follow like the order of operations. Since all of this is in the numerator, you do that first and then divide by 2 second. So what I know is 10. And to what I know, I add on 2 and then I divide by 2. So 12 divided by 2 is 6. Now I know 6, and I have to add on 2 and then divide by 2. So that's an 8 divided by 2, which is 4. And now I know 4, and I have to add on 2 and then divide by 2. So 6 divided by 2 is 3. So my sequence is 10, 6, 4, 3. And of course it continues, but they only asked me for the first 4. On something like number 3, they're asking for the 6th term in a sequence. So when it's a recursive formula, you have to just continue the pattern that you see. So it looks like I add 2, then I add 3, then I add 4, and then I add 5. So now I have to add 6. So I get 22. 1, 2, 3, 4, 5, 6. So I'm done. I just had to find the 6th term, which is 22. On B, though, they don't give me the sequence, they give me the formula. So you got to take it out to the 6th term. So the first term is a -2. Second, third, fourth, fifth, sixth. Once I fill in my blanks, I found the answer to the problem. And all they're telling me is that it's arithmetic. All I'm doing is subtracting 10 each time. So I get -12, then -22, then -32, then -42, then -52. So what's the 6th term in a sequence? It's -52. And then on this page, these are word problems. It's our last page. What I would suggest, but of course it's up to you, I would suggest you pause the video, you go try and do the word problem without hearing the things that I have to say, and then listen to what I have to say and make sure you're right. So hit pause, give it a try, and now I'm going to go for it. So the sum of the interior angles of a triangle is 180. So that's with 3 sides. The sum is 180. And then a quadrilateral has 4 sides, and that's 360. And then a pentagon has 5 sides, and that's 540. And assuming this pattern continues, find the sum of the interior angles of a dodecagon. Okay, so that's 12 sides. So 5 sides, I have to figure out 6, 7, 8, 9, 10, 11, and 12. And I can tell that each time we're adding on 180. So you easily can just like pick up your calculator and just keep on adding on 180 each time. You can start from the beginning, it's not necessary, but it's kind of like a check for yourself, right? Am I adding on 180? I get 360. If I add on 180, I get 540. If you keep on hitting enter, it actually just keeps on adding on that same number for you. That's like a trick of the calculator. So this is 720. And then just hit enter. 900. And 1080. And 1260. 1440, 1620, and 1800. So that brings me up to the 12th one. So to answer the question is 1,800 degrees in a 12-sided figure. It does say in the directions to write a recursive formula, so let's go for this. So the first term in the sequence was 180. Even though it represented 3 sides, it's like our first number. Some people actually like to say that they want to call this the third term. There really isn't a second term then and a first term because a shape doesn't exist if it only has 2 sides. To find, this pen's not working, the next term, I take the term that I know and I just add 180 onto that. Now in part B, after knee surgery, your trainer tells you to return to your jogging program slowly. He suggests jogging for 12 minutes each day for the first week. So I guess that's my first number in the sequence. Each week thereafter, he suggests that you increase that time by 6 minutes per week. So that means I want to add on 6 each time. So how many weeks will it be before you're up to jogging 60 minutes a day? So if we keep on adding on 6, I get 18, 24, 30, 36, 42, 48, 54, and 60. Right, I'm up to 60 minutes. This was my first week. So second, third, fourth, fifth, sixth, seventh, eighth, ninth week. The ninth week will be up to 60 minutes a day. It did ask us in the directions, so remember to write the recursive formula. So my first term in the sequence was 12. To find the next term, I used the term that I know, and I just added 6 to that. So A was an arithmetic sequence, and B is an arithmetic sequence. C, a culture of bacteria doubles every hour. So the way that bacteria grows is definitely exponential. If it's doubling, it means we're multiplying by 2. So this is a geometric sequence. If there are 500 bacteria at the beginning, those are like such key words. 500 bacteria at the beginning. How many bacteria will there be after 10 hours? And the bacteria doubles every hour. So this next thing is after the first hour, right? That's what it started with. After the first hour, it doubles to be 1,000. And then the second hour, it doubles to be 2,000. And then it doubles to be 4,000. After 10 hours, so I have to keep on doing this. First, second, third, 4, 5, 6, 7, 8, 9, and 10. I have to like keep track for myself because I lose my place. So doubling each time. Oh, that's a 4,000, right? 8,000, 16, 32, 64, 128, 256, and 512. Yes. Okay. So after 10 hours, there will be 512,000 bacteria. If we were to write the recursive formula, my first term, I'm going to say is 1,000. And then to the term I know, I will multiply it by 2. This is one way that we can write it. you are allowed to use your 0 term. You're allowed to say that a sub 0 equals 500 and a sub n equals a sub n minus 1 times 2. So you notice the second part stays the same. It's the first part of the recursive that you just have to be careful of, because this is what it started with, so it was the 0 term. And that's the only thing that gets a little tricky about sequences, about are you given a 0 term or are you given the first term? And it comes down to wording. You got to be very careful of your wording. So good luck, and I'll talk to you soon. See you, bye.